Yo, what's going on, guys? Welcome back. Today we are doing day 8 of the advent of cyber, and today we are using shell codes. So shell codes of the world unite. So we're going to talk a little bit about what shell codes are. As you can see, you're going to need the attack box and a VM that they're going to spin up for you. So make sure you start those before you start reading because they do take a little bit. All right. So there's some terminology that we're going to have to know before going into this. Shellcode, PowerShell, Windows Defender, Windows API. Now, most of you probably are familiar with what PowerShell is and Windows Defender. Most of you are probably not familiar with Windows API or what actually shellcode is. So we're going to talk a little bit about that. So shellcode itself is a piece of code usually used by malicious actors during exploits. Okay. Now, the key to this is the code that is malicious, but the payload is how it's delivered, okay? And the reason I emphasize that is because you can put shellcode into multiple payloads. That's what Metasploit does, and that's why Metasploit's so powerful. So keep that in mind, that the shellcode itself is the actual code that's malicious, but it takes over the exploit, but it can be delivered in many ways, and that's what we're going to talk about, is how to deliver it properly. So now you have PowerShell, which PowerShell is a scripting language and command line shell built into Windows for task automation. Most of you probably know what PowerShell is. And you see we have a box down here, AOC shell coding v5. That is our Windows box that is going to be used to make this attack happen. So then you have Windows Defender. It's a built-in security feature that detects and prevents malicious scripts, including PowerShell-based attacks. Now, the thing to know about this is if you do things correctly and run it in, load it into RAM, which is what they're talking about, or load it into memory, you can bypass a lot of defense, okay? And that's kind of what they're talking about. Now, common bypass methods for evading Defender include obfuscating scripts to disguise malicious content. This has been around forever. Most people know. I'm not just going to, as an attacker, just send you a file and say it's, hey, this is malicious.exe, run it, right? We're going to disguise it. We're going to make it very hidden so even the computer goes, oh, this is actually legit, right? Another technique is reflective injection, where malicious code is loaded directly into memory. That's what I was talking about. Avoiding detection by signature-based defenses, because it never runs on the hard disk. It's never detected, right? Now, the Windows API, this is where a lot of people don't know that this exists. This is how a lot of EDRs and things like that operate, is they use this Windows API. And the Windows API allows programs to interact with the underlying operating system. So what this API does, it's crucial because many exploitation techniques and malware rely on it, right? Because it allows you to manipulate processes, allocate memory, and execute shellcodes directly on the machine. Common API functions frequently used by malicious actors are virtual allocation, create thread, and wait for single objects, which we're going to use. Now, this may be over some of your guys' head, and that's fine. There's nothing wrong with that. But the Windows API allows you to basically put yourself in between things that run. So what that means is, let's say I wanted to run whatever, syslog or something, right? That's just an example, but you can put that API there, right? You can hit that underlying before, which allows you to work with the memory management, file operations, all that stuff. It allows you to interact with the underlying operating system, meaning you're not looking at the application layer anymore. You're actually laying yourself underneath it, which means you can put yourself, I hesitate to use the word, but basically kind of like a man in the middle, but you're underlying the operating system. You're on the underlying operating system, whereas applications are running on the top of it. So you can kind of inject yourself into that is what's happening. Now, accessing Windows API through PowerShell reflection. So this is where Windows API via PowerShell reflections is an advanced technique that enables dynamic interaction with the Windows API from PowerShell. So what does that mean? Instead of relying on pre-compiled binaries, so like PowerShell, if you run like get content, right? That's a pre-compiled binary. That's something that is already pre-compiled. It's going to do what you tell it just by running an alias, right? Now, what that means is PowerShell reflection allows you to call Windows API functions during runtime, or directly at runtime, meaning you can tap right into the underlying operating system and will enable you to manipulate low-level system processes. So again, you're working on those underlying things that are making the machine run. You can inject yourself into that, right? So it allows you to bypass security, because does all security run on a kernel level? No. So what does that mean? Well, if you're not on that kernel level, and we're underneath you, right? As an attacker, which means anything I run isn't going to be seen by you. Okay? So it allows you to execute code stealthily. All right. Now, reverse shell, you guys should be familiar with this, but basically what this is I exploit something and I tell it to connect back to me. The reason I do it this way is because that makes it, for one, not all exploits are stable. For two, it allows me to have a full interactive shell with you, and I can, actually start uploading, downloading, manipulating, doing anything I need to do for persistence. Whereas an exploit sometimes is limited functionality, or it might be much more difficult. A good example of this, is remote code execution that I might have maybe in a web browser. Maybe I have a way to run commands on your machine in a web browser. That's great, but it might be very difficult to keep trying to, for instance, when you're using Linux, right? If I just want to use, let's see if we can get shell up here. Right, here's one. If I just want to go right here on the terminal and say ls, right? And then I want to say cd into desktop and then ls, right? If I wanted to do this and I already had taken over your machine, but I did it with a web app, I have to rerun that payload over and over and over with new commands and try and manipulate it. Whereas if I get a shell, I interact just like this on the desktop. It's really nice. So that's kind of the reasoning for reverse shells. There's other reasons too, but that's the basics, right? All right. So now, Mayor Malware's minions, Sneaky and Sly, found his script and gave it a try. They tampered the code, changed the port IP, twisted his work in a sinister glee. So basically, he's got minions, and they're going to try and bypass the defenses, because if you remember, Mayor Malware tried before, and he actually got caught by our stuff. Now, we're going to make sure he doesn't. So, first thing we're going to do is we're going to run this MSF Venom. If you guys don't know, MSF Venom is an amazing tool. It allows us to run using MSF Venom. We tell it, hey, we want a Windows reverse shell, right? The port we want, which is 11111 in this case. And then the attack box, and we're going to say it's 10, 10, 226, 10, right? So now we have this, and we say we want the file to be a PowerShell file. So we go ahead and we run that, and it's going to give us the actual shell code, right? It's going to generate the shell code for us to get a reverse shell. But keep in mind, this is not the payload, right? Or this is not the delivery method. This is, I said the payload, but this is the shell code that's going to go inside of that. You can see, look, we have simply the hexadecimal shell code. Now, how do we get that into our actual payload that we're going to deliver, right? That's where the next part comes in, which is the actual, sorry, it says the actual shellcode, but what we need to do is we need to load it into memory to create a thread to execute it. That's the part that gets you the underlying, because if I just ran this, well, it's just going to run in that PowerShell thread, and it's going to be busted, right? We're trying to get it loaded into memory and run in a separate thread, run underneath. And the reality is, in order to do that, we have to have some additional code here that you can see. We're not going to dive into every single piece of this code. You can see it's written in C, pretty self-explanatory if you know anything about code, but it's not crazy. The hardest part about a lot of these codes is this one's pretty easy because it's, you're just sitting there running it directly on the machine. You'd have to get this onto the machine and run, right, before you can do anything. So that's the harder part. But you can see they're going to run the kernel 32 DLL. They're going to import that, right? You can see there's the kernel 32 DLL import. They're going to run virtual allocation import. They're going to import a few things. That's great. So let's go ahead. What we're going to do is we're going to say we want a new document, empty file. We'll name it, what do we name it? Who cares? Shellcode, whoops, typing over here. Need to be typing over here. We'll just name it shellcode. Doesn't really matter what you name it. We'll open it, because what we're going to do is put this in here. So, boop. Okay, did not mean to do that. We want to copy, put it in there, and you can see there's a placeholder for the shellcode. So we just take this shellcode, copy it, go down to the shellcode placeholder, and paste it. Right? Now we have a payload with our actual shellcode in it. Perfect. So now we have a full payload that we can deliver, and we can make it actually operate, right? And so they're going to break down the code. So we're not going to, it says don't stress, blah, blah. We'll break it down step by step. So the first thing that we're going to do is the DLL import, right? Which allows you to get the kernel 32 DLL, which is part of the Windows API. So this is allowing us to use that Windows API that we talked about. Now you have the virtual allocation. This function allocates memory in the process address space. It's commonly used in scenarios like this to prepare memory for storing and executing shellcode. So what we're doing is we're saying, hey, memory, be ready. We need to allocate so much memory to something we're about to do. And this is where the create thread comes in. Function creates a new thread in the process. So we're not in the parent process, or we're not in the original process. Now we're creating a new thread. That thread will execute the shellcode in memory, right? Now wait for single object. This function pauses execution until a thread finishes. It ensures that shellcode has complete execution. What that means is you don't want to move on to the next step until we are sure this one's done. If you don't do that, what can happen is, let's say something gets hung up or a computer's slow or anything, you can jump ahead and start missing things, right? These are then added to PowerShell using add type command, allowing PowerShell to run these functions. Okay, cool. And the reason I'm skimming over this is because this is way more complex than this box is actually showing. What I mean by that is, in order for you to do this from scratch, this box is not going to get you there ever. You need to have some coding language. You need to have some background and things like that. They're showing you, because they even say in here, a lot of pen testers don't create their own payloads like this from scratch. They're going to create this piece and put their shellcode in an existing payload, okay? So now, storing shellcode in a byte array. So the next script stores the shellcode in a buff variable. Now you can see in the MSF Venom, they did the same thing. They already named it buff, right? So it's pretty easy to transfer. We just look for the buff variable, which is right here. Buff equals, there's your variable, right? So, okay, so the shellcode placeholder is just there to show you where you'd insert the code, which we already did. Usually you'd replace it with the real shellcode, which again, we did. So the virtual allocation function then allocates a block of memory where the shellcode will be stored. So if you look at the virtual allocation, if we can find it without digging too deep. There you go. So it's telling it, hey, it's up here, getting ready, right? So it's the first thing they call on. 0 for the memory address, perfect. Meaning the Windows will decide where to allocate the memory. Size for the memory block. So just got to find the, if you go through here and look, there will be a size. And that's telling it, that's going to be based on the size of your payload, because you're going to need to tell it, hey, how much memory do I need? And you can see here there is, I don't know why it's missing, like, I don't know if you guys can see it. There we go. For some reason, that bottom line was gone. And this is very small, I'm sure, for you guys, so it's going to be hard for you guys to read. But you can see they kind of address the variables there. Perfect. Then the script then uses the wait for single object function, which again is just making sure that it actually runs, because, and that's, you can see the last thing, it's making sure it runs. This makes sure the shellcode runs completely before the script ends. So it makes sure it doesn't run through this, something is like hung up or waiting or delayed, and then it just keeps going and closes out the thing. So now all we got to do is start our netcat process, which is netcat nvlp, which is going to be, all this does is literally just sits there and listens. So this is sitting here listening, waiting for a connection on port 1111. You can use whatever port you want, but keep in mind, if you change the port on here, you have to change the port on the payload itself, which is right up here. You notice we specified 1111. You'd have to change that, so make sure you know that. Now, this is where it's going to be kind of a pain in the butt, because I have to copy and paste from this machine to the other one. But now they're showing you how to do this, but they're not showing you how to get it onto a machine, right? Because there's so many different ways. This is kind of like, this is just one method. Keep that in mind. One method of getting shellcode to a machine, right? What I mean by that is, yes, we built this whole payload out that we can run in PowerShell, right? But this is not the only way to run shellcode into a machine. So keep that in mind. Okay, so now once you've added the shellcode, navigate to the attached VM, open PowerShell. So let's do that now. All right, and we're probably just going to copy from over here because I don't really want to. I don't want to do this. Go back and forth because you saw that it loads. So here's PowerShell, and you can see we're logged in as user Glitch, which, if you remember, that's who Mayor Malware is pretending to be because everyone thinks Glitch is a bad guy, but in reality he's not. Okay. You recently created the Windows PowerShell window. For example, the first part to copy and paste is the block below. So what we're going to do is we're going to copy all this, and this is just prepping the environment. It's very common that you're going to have to prep an environment for what's going to happen because it doesn't know what you're trying to do. So you hit enter. Okay. And then we wait. Then it says paste the line below, replacing the placeholder with the shellcode generated from MSF Venom, right? Well, if this doesn't stay frozen, we can do that. There we go. Okay. So now we'll go back to the attack box and we'll copy our byte shellcode, right? So right here. Boop. And there we're going to say boom. Because this is just setting up the variable. So we're just still, again, prepping the environment. Okay. See if that loads in. I don't want to hit too many buttons because it's going really slow, so I don't want to like have to copy and paste this twice. Okay. I just don't think it's going to work. Okay. So just did not work. We'll have to go back. So what we'll do is we'll copy and we'll use the little, so sometimes I have to use the clipboard, sometimes I don't. So that's the thing. So now we'll go over here. Go over here. There is no clipboard now. Interesting. There we go. Okay. Finally worked. So we set that variable. That is the variable buff, right? Okay, so now that's loaded in. And then this one you have to do line by line, okay? Line by line. So what you're doing. So pay attention to what you're doing. I know it's very small for you guys, but you got to do it line by line because you're doing each process individually. You're loading it into memory is what you're doing. And then once it's loaded into memory, it'll say wait till everything's done, right? And make sure you wait till each one's done. Don't. So then this one's going to say wait till it's completely executed. And let's go. Okay, and the reason we do that, again, we talked about it, but also now we go over here to the attack box. And look at that. We have a shell. Now, if we go back over here, check this out. See how it's still running? It's still sitting there. If we didn't wait for the single object for the process to execute, most likely this would just close the shell, right? We want it to wait until we tell it to close the shell, right? Now, it says here, once you execute the final line in PowerShell, enter your guy reverse shell, blah, blah, giving you complete access. So we have complete access, right? So now Glitch must act. No time to delay. To fix the shellcode and keep foes at bay. He tweaks and he codes at to set the wrongs right, protecting his secrets with all his might. So let's dive into the story and troubleshoot the issue in this part. Glitch has realized he's no longer receiving incoming connections from his home base. So the story is, if you guys didn't see the beginning, Glitch went to, he was going to a tech conference and he was going to remote into his machine at home, but he noticed Mayor Malware had minions near his house. So they must have went in and done something. So Glitch realized he can't receive incoming connections from his home base. Mayor Malware's minion team seems to have tampered with the shellcode and updated the IPs and the port meaning glitch can no longer connect, right? The correct IP address for glitch is attack box IP, and the successful connection port should be 4444. Can you help glitch identify and update the shellcode with the correct IP and port to restore the connection? Okay, so now what is the flag value once glitch gets reverse shell in the digital vault using port 4444? Well, what we should have to do, is we should be able to just, let's go to desktop here. Whoops. And it says here, it'll take about what it say, a minute for the thing to appear. So all we're going to do here is I close the shell. I'm going to go up to MSF Venom. I'm going to create the shellcode for 4444. So I just change the L port to 4444. Hit enter, right? And then we'll go ahead and change this code because, whoops. All it's going to change, all that needs to change in our code is this. So we're going to say, here's our hex code, right? And then we'll keep it there. Now when we go over here, whoops, go back to TryHackMe so I can get the whole thing because I want the buff. So now I want the buff variable. So make sure you get byte, buff, the whole works, right? Because you're just setting a variable. Notice PowerShell closed. That's because we closed it. Now we should be able to, if it's going to load, okay, we should be able to just run this again, exact same way. Let that run. There you go. Now we just need the place or the code. So we'll just say we want this whole thing, right? And we'll put it back in the clipboard just in case. There we go. Now we'll go to the shellcode. Come on. All right, it's not copying, and there is no clipboard on this one. So we'll go back to the clipboard, copy. So now we'll go back into our regular computer, copy this whole thing. All right. And hopefully we can get it to, the copy and paste on TryHackMe is always a little finicky, and I'm not sure why. There we go. So now that should run. Now we just come over here. And we got, don't forget, before we forget, because I almost did, make sure your Netcat listener over here is set up. And make sure you change it to port 4444, or else it's not going to work. So now we'll copy this. And just do these line by line. And it's not really super important that you guys understand this code, which is why I'm not going to dive into it. Because it's, if you don't know the programming language, like what's the point of the code, right? Because you're going to need to always kind of manipulate code and things like that. You may not have to write it from scratch, but you're going to always have to manipulate it and understand it. All right, so now when we do the final, you should see it stay open, hopefully. Go back to the attack box, and there we have our little shell, and we can say cd. I think it said it's going to be on their desktop. Note the flag takes around a minute to appear in desktop directory. Yep. So they actually tell you to use type, which kind of tells you what's crazy is they're telling you to use shellcode and hack into this, right? Before you even understand how to use PowerShell command line. That's kind of wild. But You can see they're telling you to go to flag.txt. You can see I tabbed it and I didn't get anything, so let's see if it's even there. Yep, it's not there yet, so we'll just cd into desktop, and we'll just say dir, and there it is. Okay, so now type flag.txt. There you go. AOC got my access back. So now I say copy, paste, and there you go. There's your shellcode, guys. So pretty cool little box, fun. Teaches you a lot about how shellcode is inserted into a lot of payloads, and hopefully you guys learned something. Hopefully it didn't go so far over your guys' head that it didn't really teach you anything. The point is not to copy and paste everything. It's not to read the coding. It's to understand how these processes work and to understand the Windows API and things like that. So try to focus on that stuff. Let me know what you guys think, and please hit that sub button, hit that like button, guys. Thank you so much. Have a good one.